Hey, welcome back everybody. This video is about leaning the engine. And I will be completely honest, when I was a student pilot, I really didn't maybe fully understand or maybe really care about leaning the engine. It wasn't my gasoline. I was paying a wet rate. So what do I care if I save any gas? Well, guess what? Now, one, as an airplane owner, and two, as a pilot flying 5 hours a day, trying to conserve fuel, I do care about leaning. And I care about taking care of this engine because I'm over some hostile terrain, and I want to make sure that it is healthy for both me and the next guy who flies it. So let's check this out. I hope the video makes sense, and please like and subscribe and thumbs up and all that stuff if you would be so kind.
Okay, welcome back, flying fans. Today we're going to talk about leaning of our engine. Let me get rid of that. Leaning of our engine, the fuel-air ratio mixture. What I am not going to try and tell you is to run rich of peak. I'm not going to try to tell you to run lean of peak. We will discuss what they are, but those are highly charged opinions that are best left to the owner-operator of a particular aircraft. So let's jump right in. An engine needs three things to run. We all know what they are. We need some fuel, we need some air, and we need a spark, like a lightning bolt. Fuel and air and our little lightning bolt. So it just so happens that the perfect ratio between fuel and air to ensure complete combustion is 1 part fuel, gasoline, 14.7 parts of air. This is by mass. It can be 1 pound, it can be 1 gram, doesn't matter. It's a ratio. And this ratio is called stoichiometric ratio. All right? The ratio at which there is complete fuel burn, nothing left over, no residual. Now, stick with me for a second. We're talking about a normally aspirated, basic internal combustion engine, okay? I'm not talking about turbochargers or superchargers or anything else chargers, okay? So, when I say the following, don't jump all over the flame bandwagon. We can only control the amount of fuel that goes in the engine. We cannot control the amount of air that goes in the engine. If we're at 5,000 feet altitude, there is going to be less air going into our engine, okay? Just roll with me on that. So in order to keep this ratio alive, we have to reduce the amount of fuel that's going in, all right? So very basically, if we put air over here and fuel over here, there exists a point where certain mass of air requires a certain mass of fuel. Less air requires less fuel. Okay? So I hope that all makes sense. What we're going to look at now is leaning of the engine. Okay. Draw a graph here. Down here, we're going to talk mixture, or essentially fuel. And as we go this way to the right, it's more lean. Okay, we're taking fuel out. Over this way on the graph, we're adding fuel in. And right here is the temperature of our engine. So if we are 100% full rich, we're going to have a very low temperature, engine temperature. Why? Because the gasoline has a cooling effect on the engine. And as we start to take gasoline out or away, that engine temperature is going to rise. Why? Because there's less fuel, excess fuel, that is cooling our engine. So let's start to take some gasoline out here. We're climbing in altitude. Maybe our density altitude is higher for the day. There's less amount of air entering the engine, so we need less fuel going in. So we start to lean our mixture, the red knob's coming out, and at some point we notice that it starts to flatten, okay? And if we continue to lean, then it drops off and the engine gets cold again, right? How do we see this? Well, on many basic aircraft, you don't have anything. You don't have any gauge at all. And so you don't see this rise. You don't see this temperature going up. All you see or hear is the engine increasing in RPMs and then decreasing. Well, that increase in RPMs, that's essentially the temperature going up because we are approaching that optimum stoichiometric ratio, okay? However, many light aircraft have an EGT gauge. Cylinder head temperature gauge will also work. A lot of airplanes have these nowadays. And what we see on the dial is something like this. There's a needle over here that's down here, and there are no values associated with this gauge, with this dial. There's just like hash marks, and each one probably represents 25 degrees. A lot of them say that, 25 degrees Fahrenheit. But what we see as we begin to lean out our mixture is this needle starts to rise, okay? And it goes up, and then at some point it starts to fall. And when it falls, it's coming back down, okay? Well, the point at which it achieves its maximum temperature, that's peak. That's right here, okay? Everything on this side is called rich of peak. Everything on this side is called lean of peak. So as you pull the red mixture knob out and this needle gets to its highest point and then it comes back down, that is peak. That's what you're looking for, okay? Now, many POHs say to run rich of peak. Again, I'm not going to go into the merits of each or what equipment you need, but we're going to talk about rich of peak here, okay? So in the 172 that I fly, I'm instructed to run rich of peak. That's what my boss says, so that's what I do. So when I see this temperature gauge, new color for y'all, when I see this temperature gauge start to fall, well, I start to richen back up, okay? And then it'll get to its peak value. And then if I continue to richen the mixture, it will start to fall again. Why? Because we're right here and we're coming back down. And as I add excess gasoline in, it cools the engine. So I'll come down 4 marks, new color. I'll come down 25, 50, 75, 100. I'll put the needle right there. And now I am 100 degrees rich of peak. Okay, I hope that makes sense. You can operate lean of peak, and I encourage you to read about that and see if it's right for you and if your engine or if you have the right equipment to do that. Again, this is not a debate on that, but this was simply to show you where peak is, where rich of peak is, and where lean of peak is. So we are going to go out to the airplane now. I am going to take off. We will climb. We'll probably climb pretty high, and somewhere near 9,000, 9,500, and I'll show you this leaning process. Now keep in mind, it is a slow process because you can easily blow through this peak very quickly. If you are so fast on the mixture knob, you'll never see peak, and the needle will it will rise and then it'll fall, and you don't know where you're at. So it's a slow process. Bear with, but it's important that you see what it looks like on the gauge.
Okay, here we are at 7,500 feet. I'm all leveled out. I'm doing about 2,300 RPM. Again, I have, let me see if I can get you in here. I got nowhere to go and all day to get there, so why be in a rush? Mixture is full rich. The EGT gauge is showing at the very bottom here. And remember, this does not have a numerical value, although it says 25 degrees per division. It does not mean it's at 1,000 degrees or 1,200 or 600 or anything. It's simply, this needle shows a trend, what the engine is doing. We've got fuel flow over here. A lot of airplanes don't have that on the smaller GA side, but yeah, it's pretty nice to have it, and we'll see what happens here. So what I'm going to start doing is start leaning out the mixture, and the reality is you can start doing this at any altitude, but it's most pronounced when we're up here higher at altitude. So I can't get both in the same frame. So just watch what our EGT gauge does here. Remember, we're rich at peak now. We're running full rich. So I'm just pulling the mixture out here slowly. Give it a second, see what it does. All right, I've got nothing so far. Hey, there you go. EGT is starting to rise. We're pulling the gasoline out. We're getting closer to that perfect ratio, that stoichiometric ratio for 7,500 feet, whatever it is. You also notice that our fuel flow went down. We're saving gas. So let's pull this out a little bit more. Listen to the engine, make sure we're not losing RPM. All right. Needle stuck a little bit there, so big jump. And in case you're wondering, this is let me do it this way. This is a movable needle, it's just a marker, just an indicator. So I can set that at the peak and kind of remind myself of where it's at. All right, let's pull a little more out on the mixture, see if we can get to peak here. We're still rich of peak. I'm still leaning it out. All right, needle's gone up another 25 degrees at 1 hash mark. We're down about 7-ish gallons per hour. The important thing is don't pull the mixture out too fast. You're going to blow right through peak and you'll never know where it was. It's a patience game. You've got to be patient. And I'm still waiting. I'm not pulling any mixture out. It's still on the rise a little bit. Okay, let's pull. I can kind of hear the engine start to maybe stumble just a little bit. And if you miss it, if you miss the peak and you go too lean, you'll know because the engine will start running rough, and 2, you'll start to lose the temperature here. So I'm going to set this marker here because I'm getting close, I know that. So I overlay that. Now let me pull some more mixture out and see what happens. Okay, we've got a drop in RPM and a drop in the EGT. So now I'm lean of peak. Let's go back to peak. Okay, engine picks up a little RPM there. Now, if you didn't have EGT, that would be a great way to do it. Listen for the engine stumble and then richen it up a little bit. It's not an exact science at that point, but it sure gives you better than it was before you leaned it. I'm going to go rich a little bit more, see what happens. I'm just doing a quarter to eighth to a quarter turn at a time. I gained a little bit of temperature there. Not much. Okay, I just richened it a little bit more. Okay, another little, richened a little bit more. Now you see the needle starting to come down, so that was peak. That little eighth of a turn that I did has brought the temperatures back down. Eighth of a turn, making it richer. So I came down 1 hash mark, so I came down 25 degrees. Let's go a little bit more, rich. All right, I'm down another hash mark. So there is 50 degrees rich of peak. I'm going to richen a little bit more. Again, just small turns at any one time. Looking to see what happens. Alright, it's almost down 3. Alright, so there is 3 hash marks. That's 75 degrees rich of peak. So, you can set your engine wherever you want, 75, 100, 150, rich, lean, whatever you want to do, but that's how you find rich of peak or lean of peak. And with a simple instrumentation like this, you can pull the fuel flow down pretty good and pretty accurately. And look, we're running about 7.5 gallons per hour. Way better than the 10 that we were before. So, that is rich of peak and lean of peak. Okay, that's it. That is how you lean your engine. That's how you find rich of peak or lean of peak. It doesn't matter, either one, the concept and procedure is the same. And remember, if you like the video, please subscribe, like, and all that stuff, and help spread the word. We'll see you later.